Hi guys, today we're going to talk about subtraction of integers. The rule for subtraction of integers is quite interesting because we just have to make some alterations and then after that we go back to addition. So basically all you have to remember are the rules for addition. And on that note, I bet that it's a must to review on addition of integers since number 1, addition and subtraction are inverse of each other, and number 2, like I just said, a little alterations on the subtraction problem and we are done. We go back to addition. Now if you want to watch again that video about addition of integers, just click on the link in the description box below, and you might as well want to click on that subscribe button and all the same drills that you do when you subscribe to other channels. Now say we have positive 35 plus positive 16, what do we get? Since they are of the same sign, we add their absolute values and that is equal to 51. And since they are both positive, we simply affix the sign that they both used, so we will have positive 51. The same thing goes for negative 28 plus negative 32. Since they are of the same sign, again we add their absolute values, which is equal to 60. And then since they are both negative, we affix negative as the sign of their sum. Now for different signs, say we have positive 48 plus negative 12. Since they are of different signs, we subtract their absolute values and that is equal to 36. And since positive 48 has the higher absolute value, the sign of their sum is positive, so we will have positive 36. Lastly, say we have positive 25 plus negative 32. Again, we subtract their absolute values since they are of different signs, and that is equal to 7. And for the sign, we will have negative since negative 32 has the higher absolute value. With that, I believe that we are now ready for subtraction. But before we dig deeper into this operation, let us first recall the terms in subtraction. Here we are going to match the integers with the words as to how we call them. Say we have 10 minus 2 equals 8. Below them are the words difference, subtrahend, and minuend. So what do we call the number 10 as far as subtraction is concerned? That is minuend. How about the number 2? It's the subtrahend. And the resulting number 8 is obviously our difference. In addition of integers, we illustrated the operation using the number line as our aid for deriving the rules. Here in subtraction, we can also use that, but today, I want to use blue circles for positive integers and red circles for negative. Well, basically, you can use any two colors to represent positive and negative integers respectively. I just came up with blue and red. But guess what? You can even use like icon for positive and dislike for negative. Whatever makes you feel comfortable, that's democracy, I believe. Now in this activity, let's think of the word minus as take away. So say we have 100 minus 80. We think of it as take away 80 from 100. So without so much ado, let's get it started. Say we have positive 8 minus positive 3. For positive 8, we will have 8 blue circles and then we have minus positive 3, which means we have to take away 3 blue circles from the 8 blue circles. What is left for us are 5 blue circles, and these 5 blue circles represent the difference or the answer. Hence, positive 8 minus positive 3 equals positive 5. Pretty much our elementary way of subtraction, that is 8 minus 3 equals 5. We just put in the plus signs to emphasize their being positive. Now how about positive 8 minus negative 3? What do we get? Alright, again for positive 8 we will have 8 blue circles, and for minus negative 3 we will have to take away 3 red circles since it's negative. Now the question is, how are we going to do that since we don't have any red circle in the minuend? Very tricky, yeah? Now pay very close attention. Since there are no red circles in the minuend, we will add 3 red circles in there. But we don't just simply add 3 red circles there. Of course, mathematics has its rules. Now here's the thing. We add 3 red circles in the minuend, but at the same time, we also add 3 blue circles. Why? Let's put it this way. Say you're playing in a bet game and you have 8 pesos in your pocket at the start. After the first game, you lost 3 pesos. So that means you are left with only 5 pesos. But soon after the second game, you won 3 pesos. Then you'll get back to what you had at the start, which is 8 pesos, right? These are called zero pairs. Zero pairs they are called since they outdo each other. So in 8 blue circles, if we add 3 red circles, but at the same time, we also add 3 blue circles, the value of the minuend is still positive 8. It just looks different, but still the same value. In this case, we can already take away negative 3 or 3 red circles from the minuend. After doing so, what is left for us are 11 blue circles, which is equivalent to positive 11. Now if at this point you are starting to figure out how it works, then you can start solving this next problem ahead to see if you're right. Say we have negative 6 minus positive 4. The minuend will be represented by 6 red circles. Since it's negative, then we have to take away 4 blue circles since our subtrahend is positive. The same problem happens here with that of our second problem. So we add 4 blue circles, but we also add 4 red circles to keep its value as is. And with this, we can already take away positive 4 or 4 blue circles, and what is left for us are 10 red circles. Therefore, the answer here is negative 10. Now let us put back all the 3 problems that we've had. For positive 8 minus positive 3, we have positive 5. For positive 8 minus negative 3, we have positive 11. And for negative 6 minus positive 4, we have negative 10. Alright, I am giving you 30 seconds to analyze how we can subtract integers without using the manipulatives. If after 30 seconds you haven't formulated the rule yet but want to finish it, feel free to pause the video for a while until you're done so, but don't skip this video just yet. Your time starts now. Okay, time is up. Let's test your rule against this problem. For 5 seconds, negative 15 minus negative 8. Go. Alright, time is up. The correct answer is negative 7. If you got it right, 2 thumbs up for you. But if you got it wrong, I am perfectly fine with that. Now let's collect all the 4 problems all together. For positive 8 minus positive 3, we have positive 5. For positive 8 minus negative 3, we have positive 11. For negative 6 minus positive 4, we have negative 10. And for the latest one, we have negative 15 minus negative 8. That is equal to negative 7. Here we go. I want you to compare the results of these problems to the addition problems at the right. Alright, I have some questions here for you. Do these problems at the left have the same answers compared to their corresponding problems at the right? Yes, and therefore, in subtracting integers, we will go back to addition. But we don't just change the operation from subtraction to addition. Let us compare at least the first problems. For positive 8 minus positive 3, that is equal to positive 5. It has the same result with positive 8 plus negative 3, which is also equal to positive 5. Now the question is, When we shifted to addition, did the minuend change its sign? No, we just copy that. Of course, the subtraction sign is changed to addition sign. And how about the subtrahend? Did the sign change? Yes. Therefore, in subtracting integers, we add the additive inverse or the opposite of the subtrahend to the minuend. But for some lazy mathematicians, well, it's just a pun. But quite seriously, we don't like memorizing very long sentences or paragraphs, so they came up with a shortcut to that rule, and that is copy, change, change. But we must have to be able to understand what these words stand for. Copy is for the minuend, meaning we don't change anything. The first change, or the second word, is for the operation sign. Of course, from subtraction, we draw a vertical line cutting it across to change that to addition. And the second change, or the last word, is for the subtrahend, which needs to be replaced by its opposite, or the so-called additive inverse. That's what the copy, change, change means. And there you have it, guys. Before we end up this video, let us, as usual, have some exercises. Remember, copy, change, change. Then we proceed back to addition. For 5 long seconds, positive 21 minus negative 12. Go. Alright, time is up. The correct answer is positive 33. Another 5 seconds. Say negative 30 minus positive 25. Go. Alright, time is up. Correct answer is negative 55. Another 5 relaxing seconds. Negative 22 minus negative 33. Go. Okay, time is up. Correct answer is positive 11. Till next time.